In this question, we want to determine the distance between the two lines shown. Well, there are different approaches to this. One of the approaches is to recognize that since the lines themselves aren't parallel, they're either skew or they intersect at one point. And regardless, what we can do is create two parallel planes by using the point on one and then crossing the direction vectors of the two lines to get the equation of one plane, and then using a point on the other and crossing the direction vectors of the two lines to get the equation of the other plane. So what we're going to do is take that second method. So when we cross the vectors 1, -6, 3, and 3, 8, 9, we come up with a normal vector of 78, 0, -26. What we're going to do is simplify that to 3, 0, -1. So the equation of both planes in question are 3x plus 0y minus z plus some value of d equals 0. Well, let's take the first plane, or sorry, the second plane. A point on that is 2, -1, -5. Knowing that we've got the equation 3x minus z plus d equals 0, and plugging in 2, -1, -5, we see that an equation for that plane is given by 3x minus z minus 11 equals 0. Well, the distance between these two lines will be given by the distance from this point, which is on the second plane, to this plane right here, 3x minus z minus 11 equals 0. Well, that distance is 3 times -3 minus 0 minus 11, absolute value, over the magnitude of the vector 3, 0, -1. And that's 20 over root 10, or in other words, 2 root 10. So the distance between these two lines is 2 root 10. That approach has one advantage over the other approach, which is that it's relatively quick. However, one disadvantage is it doesn't give you the points in question on each of the lines that provide that minimum distance.